Hi students, welcome to Physics with ER regarding Earth satellites. So before going to discuss about this, we have been discussed the concept of geostationary satellites and polar satellites. So now the satellites which revolves around the Earth, such kind of satellites which we can call it as Earth satellites. Objects which revolves around the Earth are called Earth satellites. This motion of Earth satellite is very similar to that of planets around the Sun. Hence, Kepler's laws of planetary motion can be applied. So, if you have no idea regarding the Kepler's laws of planetary motion, I have been done an video. I have been given in description. Please watch it. Right. The orbits of Earth satellites are circular or elliptical. So it depends upon the speed in detail, which we are going to study about this in this class. So Moon is the only natural Earth satellite. So this also you know, the orbit of Moon around is nearly circular. The time period of Moon around the Earth is approximately 27.3 days. This time period is roughly equal to the rotation of a period of motion about its own axis. So due to this region, we always observe only one side and we are not able to see the other side of the. So apart from this natural satellites, number of man-made satellites which are called artificial satellites are launched into different orbits around the Earth. So if you have been seen, mainly which we can see it as nowadays for communication purpose, a telecommunication, or which we are using for mobile. So all this comes under these artificial satellites. So what's the time period of Earth satellite? How much time it will take? So for this, which we can do the little bit of calculation part. So based on what we know from previous knowledge. The velocity with which the satellite is launched makes it to revolve around the Earth in a particular orbit. Whenever it is moving in particular orbit, so what we can consider. So consider a satellite revolving around the Earth at a height h above the surface of the Earth. The satellite revolves the Earth in circular orbit at a height re plus h from the center of the Earth, where re represents radius of Earth. Whenever satellite is revolving around the Earth, that because of centripetal force, that centripetal force which is equals to, which is nothing but, which you can call it as a gravitational force. Let Re equals to radius of Earth. So small h is the height of the satellite from surface of the Earth. M is the mass of the satellite and m is the mass of the Earth. So whenever satellite is revolving, it's required some centripetal force. That centripetal force already which you have been proved it as, which is nothing but, so F centripetal force, so which is equals to, we have been proved already, mv square by r, that r value which you have been taken it as re plus h. Its direction towards the center of the Earth. The centripetal force is provided by the gravitational force. So from the figure, just we can understand it as like this. If re is the radius of the Earth and h is the height, if one satellite, so which is revolving, so like this, so based on this, now which we are going to prove the time period. So that always satellite which will tries to attract towards the center of the earth, that's which is nothing but centripetal force. So we have been already proved that gravitation force is nothing but capital G into small m into me by re plus h whole square. So with the help of what you have been studied at the beginning. So for circular motion of satellite, so that centripetal force which is equals to the gravitational force. By applying both the equations, by equating, we can get it as, with the help of this, v square value is equals to capital G into capital me into re plus h. Here you can see that which is nothing but, so this m and this m which is going to be gets cancelled. I required only v square value. So this is similar to that of, if you have been observed, orbital velocity, so which you have been studied in previous concepts. So with this, what we can tell, if h increases, what about the v value? So v value will be decreases here. Why? Because v is a square directly inversely proportional to square root of its height. For a satellite nearer to the surface of the earth, h is negligible when compared to re, because radius of earth is around 6400 kilometers. So with this we can write it as v value is equals to capital G into me into re. So already we know, so relation between small g and capital G, which you have been proved it as, so which is nothing but a small g is equals to capital G into me into re square. With this which you have been taken, we can write it as that value as like this. So multiplying both sides with respect to, dividing with respect to re, so we can get it as, so which is nothing but v is equals to root g into re, so which we have been obtained. This is similar to that of orbital velocity, so what you have been studied in previous classes. So v is independent of mass of the satellite. So with this we can find the time period of Earth's satellite. The time taken by the satellite to complete one revolution around the Earth is called time period. So if you have been studied in previous classes, which is nothing but speed is equals to distance by time. With the help of that, time t is equals to, which we can write it as, so which is nothing but distance traveled in one revolution by orbital speed, because we are discussing this in terms of circular motion. So based on that, for one revolution by orbital speed, which we can find out. So distance traveled by the satellite in one revolution. So if you have circumference of the circle, we can write it as 2 pi into re plus h, which we can be written. With this v value, just now we have been proved the v value. So v value is nothing but root over g capital me by re plus h. So on solving this, so if this it has been moved to upwards, so which we can get it as the above equation as, which is nothing but t is equals to 2 pi into re plus h whole to the power of 3 by 2 into root over capital G into me. Under this condition, 2 pi is a constant, so capital G is a constant, mass of the earth is a constant, so we can write it as, so and making squaring on both sides, so we can get it as this value as, which is nothing but t square. So with this, so this all which we can take it as a constant, and t square is equals to constant into re plus h whole cube. If you have been remembered little bit, Kepler's third law, we have been proved it as t square is directly proportional to e to the power of cube. So based on that, which you can be uses. So this is a Kepler's law of period, so which you have been studied in Kepler's laws.